Hi, in this video, we are going to look at how we go about tackling exponential equations where the exponential term is multiplied by a constant. Let's look at the example 3 multiplied by 5 to the power of x is equal to 75. Now, many students want to multiply 3 and 5 to the power of x, but if this exponent was an actual value, if we had 5 squared or 5 with any exponent as an actual number, we could multiply by 3. But in this case, we cannot multiply a constant by any term with a variable exponent. Here, no matter what we do, we will always have 3 multiplied by 5 to the power of x. So how do we solve for x? The only way to solve for an unknown variable that is an exponent is to get the term by itself. And we do this by dividing both sides of the equation by the constant. So in this case, we've got a constant of 3. So let's divide both sides by 3. On the left, we'll be left with 5 to the power of x. And 75 divided by 3 is 25. And now we can solve for x. We have 5 to the power of x. Let's leave it as it is. We know that 25 has got a prime base of 5 and an exponent of 2. Now our bases are the same, which means our exponents are equal. So we can see that x is equal to 2. Let's do another one. 2 multiplied by 7 to the power of 2x is equal to 98. Let's start by dividing both sides by 2. On the left, we now have 7 to the power of 2x is equal to 98 divided by 2, which is 49. Now we have a prime base of 7, so let's leave 7 to the power of 2x where it is equal to 49 also has a prime base of 7 and an exponent of 2. Now we have a base of 7 and a base of 7, which means our exponents are equal. So we can say 2x is equal to 2. To get x by itself, let's divide both sides by 2, and we see that x is equal to 1. Let's do another one. 3 multiplied by 5 to the power of 3 minus x is equal to 3. Here we have a constant of 3, so let's divide both sides by 3. On the left, we now have 5 with an exponent of 3 minus x. On the right, 3 divided by 3 is equal to 1. Now, from our rules for exponents, we know that any value with an exponent of 0 is equal to 1. So, on the left, we have 5 to the power of 3x. 5 is our prime base. So on the right, let's put in 5 as our prime base. And we need to make it equal to 1. So we give it an exponent of 0. Now we have 5 and 5, which means our exponents will be equal. So we can say 3 minus x is equal to 0. To solve for x, let's move negative x to the right-hand side, and we see that 3 is equal to x. Let's do one more example. 3 multiplied by 8 to the power of x plus 1 is equal to 48. We have a constant of 3, so let's divide both sides by 3. We're going to have 8 to the power of x plus 1 on the left is equal to 48 divided by 3, which is 16. Now we have a base of 8 and 16. So we need to find our prime bases. We know that 8 can be written as 2 cubed. So we can say 2 to the power of 3, put into a bracket, with an exponent of x plus 1 is equal to 16 also has a prime base of 2 and an exponent of 4. Now we can multiply out our exponents. So we say 2. 3 multiplied by x is 3x. So we have an exponent of 3x. 3 multiplied by 1 is positive 3. And on the right, we have 2 to the power of 4. Now we have a base of 2 and a base of 2, which means our exponents will be equal. So up here, we can say 3x plus 3 is equal to 4. And now we can solve for x. Let's move this 3 across. So we're going to have 3x on the left. On the right, we have 4 minus 3, which gives us 1. To get x by itself, let's divide both sides by 3. And we see that x is equal to 1 over 3. Please work through some exercises in this section before continuing with our videos.